I'm from CCD. My number is 21 So today in this segment, I want to explain about picture and floating point representation. Let's see what is number representation. Digital numbers use binary number system to represent all types of information inside the computer. Alphanumeric characters are represented using binary digits like 0 and 1. Digital representations are easier to design. Storage is easy, accuracy and precision are greater. There are various types of number representation techniques for digital number representation. For example, binary number system, octal number system, decimal number system, and hexadecimal number system, etc. But binary number system is more relevant and popular for representing numbers in data computer system. So let's see what are the types of notations. There are two major approaches to store real numbers, that is numbers with fractional component. In modern computing, there are fixed point notation and floating point notation. In fixed point notation, there are fixed numbers of digits after the decimal point, whereas floating point numbers allow for a varying number of digits after the decimal point. What is fixed point representation? This representation has fixed number of bits for integer part and for fractional part. For example, if given fixed point representation is given here, then you can store minimum value is 0.0001 and maximum value is 9999.9999. There are three parts of fixed point number representation: the sign field, integer field, and the fractional field. We can represent these numbers using standard representation. This range from minus 2 power k minus 1 minus 1 to 2 power k minus 1 minus 1 per k bits. One's complement representation range from minus 2 power k minus 1 minus 1 to 2 power k minus 1 minus 1 per k bits. Two's complement representation range from minus 2 power k minus 1 to 2 power k minus 1 minus 1 per k bits. This complement representation is preferred in computer systems because of unambiguous property and for easier arithmetic operations. Example, assume number is using 32-bit format which reserve 1 bit for the sign, 15 bits for the integer part, and 16 bits for the fractional part. Then minus 43.625 is represented as following. The 0 is used to represent plus and 1 is used to represent 0.01011 is 16 binary value for decimal 43 and 101 so on 0 is 16-bit binary value for the fraction 0.625. So here minus 40.625 minus is negative. So here we are taking as minus 1 as the sign bit. The advantage of using the fixed point representation is performance, and disadvantage is relatively limited range of values that they can represent. So it is usually inadequate for numerical analysis and it does not allow enough numbers and accuracy. A number whose representation exceeds 32 bits have to be stored inexactly. These are the above two smallest positive numbers and largest positive number, which can be stored in 32-bit representation as the given above form. Therefore, the smallest positive number is 2 power minus 1, which is approximately equal to 0.000015 approximately, and the largest positive number is 2 power 15 minus 1 plus 1 minus 2 power minus 16 is equal to 2 power 15 into 1 minus 2 power minus 16 is equals to 32768, and gap between these numbers is 2 power minus 16. We can move the radix point either left or right with the help of only integer. Here is 1. This is the example of fixed point representation. So now let's move to floating point representation. This representation does not reserve a specific number of bits for the integer part or the fractional part. Instead, it serves a certain number of bits for the number, called the mantiso or significant. And the certain number of bits to say where within that number the decimal place is called the floating number. Representation of a number has the two parts. The first part represents a standard picture point representation called mantissa. The second part of the designates the position of the decimal or binary point and is called the exponent. A picture point mantissa may be fraction or an integer. Floating point is always interpreted to represent a number in the following form. It is mx into r power e. Only the mantissa m and the exponent e are the physically represented in the register, including their sign. A floating point binary number is represented in a similar manner, except that it uses base 2 for the exponent. A floating point number is said to be normalized if the most significant digit of the mantissa is 1. So actually, minus 1 whole power s into 1 plus m into 2 into a power minus bias, where s is the significant bit, m is the mantissa, e is the exponent value, and bias is the bias number. Note the silent integers and the exponent are represented by either sign representation or 1's complement representation or 2's complement representation. The floating point representation is more flexible. Any non-zero number can be represented in the normalized form, which is shown here. This is the normalization form of a number. So let's see an example of floating point representation. Suppose number is using 32-bit format. The 1 bit sign bit, 8 bits for a signed exponent, and 23 bits for the fractional part. This leading bit 1 is non-stored as it is always 1 for the normalized number and is referred as the hidden bit. It is the sign bit. Then minus 52.5 is normalized as minus 53.5 is equal to minus 110101.1 with a base 2 is equal to minus 1.101011 into 2 power 5, which is represented as following. Here, in this example, 0000101 is the 8-bit binary value of an exponent value 5. Now, 8-bit exponent field is used to store integer exponents, which is in the range minus 126 to 127. The smallest normalized positive number that fits into 32-bit is shown here, and largest normalized positive number that fits into 32 bits is also shown here. The numbers are represented as the following below. The precision of a floating point format is the number of positions reserved for binary digits plus 1 for the hidden bit. In the example, consider where the precision is 23 plus 1 is equal to 24. The gap between 1 and the next normalized floating point number is known as Meson epsilon. The gap is 1 plus 2 power minus 23 minus 1 is equal to 2 power minus 23 for the above example, but this is same as the smallest positive floating point number because of the non-uniform spacing, unlike in the fixed point scenario. IEEE floating point number representation. IEEE stands for Institute of Electrical and Electronics Engineers. Has standardized floating point representation as the following diagram. The actual number is shown here, where S is the sign bit, M is the mantissa, E is the exponent value, and the bias is the bias number. The sign bit is 0 for the positive number and 1 for negative number. Exponents are represented by 1 or 2's complement representation. According to IEEE 754 standard, the floating point number is represented in the following way: half precision, single precision, and double precision. Half precision is 16 bit, single precision is 32 bit, and double precision is 64 bit. 1 sign bit for exponent bit and 10 bit mantissa for half precision. 1 sign bit 11 bit exponent and 52 bit mantissa for double precision. 1 sign bit 15 bit exponent and 122 mantissa. So here we discussed about number representation, fixed and floating point representation. Thank you.